So yesterday we finished with example 2, I believe. Was that the last example that we did? Okay. So today we're going to do example 3. Yes. All right, here we go. Write this down. This is a little trickier than what we did yesterday. Just looking at it right now, why do you think this is a little bit trickier? Because it's fractions, yeah. And it seems like most people don't really care for fractions. And I would agree with you. I would rather not do fractions if I didn't have to. So the very first step, we're going to get rid of the fractions. We're going to make it so we don't have any fractions. Wouldn't that be a good idea? Sure. So what we are going to do, I can't just like get rid of the fractions like that and they just go away, all right? Because that's not going to work. They're not going to equal themselves. But what we are going to do is, remember in algebra, whatever you do to one side, you can do the other side, right? So if I can look at these three numbers, 4, 3, and 6, find a number that 4, 3, and 6 all divide into evenly, okay? Yeah, the smallest number that they all can divide it into evenly, then they're all going to cancel out. And then I get rid of the bottom, I get rid of the denominator, and then I don't have any fractions. And then it's smooth sailing after that. Everybody hear that? All right. So you don't really have to really even work with fractions on this. You might have to cancel something out, but that's not that big of a deal. So the least common multiple, remember that phrase, okay, is 12. It's the smallest number that 4, 3, and 6 both divide into. So what I'm going to do is I'm going to multiply this by 12, that by 12, and I'm going to multiply that by 12. And I'm going to put that in parentheses, and I'm going to put this in parentheses, since that's being multiplied by something that's being added up. Everybody see that so far? Now what can we do? Now, I haven't gotten rid of the fractions just yet, but why did I do this? Because 4 divides evenly into 12, doesn't it? How many times? 3 times. Everybody see that? So the 4 divides into 12, 3. The 3 divides into 12 how many times? 4 times. And the 6 divides into that 12 how many times? Twice. So what I'm going to do, it's kind of a mess right now, so let's clean it up a little bit. And then it's going to look just like the problems that we did earlier in this section. All right, so look, all my denominators canceled out. So now I don't have any fractions now. That's nice, isn't it? That's the thing that we didn't like about it at the beginning. And so now we don't have any fractions. So that's cool. But what do we got left with all that canceling out? What's left right here? It's just a 3x. What's left here? Well, a 4 and an x minus 1. We'll do that in a second. Nope, the 12 canceled out. We don't have a 12. Is that what you said? What happens here? What do we have here? We got a 2, and that 2 is being multiplied by the x plus 3. You could keep it on the right, I guess, but normally we like to look at it on the left-hand side, so I'm going to go 2 times x plus 3. I just cleaned this up. Basically, I just rewrote this, and it looks real nice and pretty now, right? Now, this is something that we should be able to solve. Would you agree? So now it looks a little bit more pleasant, I guess, if you want to call it that. So let's do the regular algebra stuff that we would normally do now. Everybody understand how we got rid of those fractions? Found a least common multiple, find a number that all 3 of those things divide into evenly, then we canceled them out, wrote down what's left over, and now it should be clear sailing from here. So I've got 3x plus, distribute the 4, so that would give us 4x minus 4. Distribute the 2, that gives us 2x plus 6. Let's add some like terms. I can add some like terms on the left-hand side. 3x plus 4x is 7x. I'll just write this down. Now we get x's on both sides. I'm going through this part kind of quickly because we covered this yesterday. So let's get the x's on the same side. So I would put the x's on the left-hand side. And the same step. Now a lot of times, especially when you first learn Algebra 1, you put the line, you bring everything down, and then you would add the 4. But let's just do it right now. Might as well. Add a 4 to this side, add a 4 to this side. Everybody see that? We put the x's on the left-hand side, we put the regular numbers on the right-hand side. So now I can put my little line Those two canceled out. These two canceled out. Let's see what I got now. 7x minus 2x is 5x. And then 6 plus 4 is 10. Divide by 5. Divide by 5. X equals 2. And there you go. It seems like I always harp on showing your work. Is there any way that you could just have this problem and then on your homework just say x equals 2? There's no way. No way. I couldn't do it. All right, I could think all day long and try to do it in my head. There's no way. I'd get lost somewhere along the line if I just tried to do it in my head. All right, so you cannot just do that. You've got to show your work. Show your work. I said that on a few homeworks that I passed back, and I thought I had made it clear, but maybe not clear enough. But if you get a point off, maybe that'll make you remember next time. All right, example 4. Now this time, it doesn't say just solve. Like over here, I didn't write it. I probably should have. This, you could just say solve, and that's it. Because you're only solving for one thing. What's the only possible thing you could solve for in that problem? It's x. That's it. It's the only variable, right? But this one, they're going to tell you what to solve for because there's not just going to be one variable. There's going to be 2 different variables, okay? So they're going to tell you to solve for x. Solve for x. All right, so let's write this down. So here we go. We got 7x plus 18b. See, there's that second variable, equals 5b minus ax. There's a third variable. We got 3 different letters in here. All right, so our answer's not going to come out real pretty like x equals 2, like the last one did. All right, it's going to have some letters in the answer. So if I'm solving for x, what letters are going to be part of my answer? B and A. Exactly right. Everybody see that? So I want to get x by itself. So what am I going to do? We kind of did this step earlier. We've got all the x's on the same side. So I have an x on the left side. I got a minus ax. So the x is on the right side. I want to put them on the same side. So I'm going to put them both on the left side. Is that all right? So how would I do that? You can kind of do this part in your head a little bit. You're still showing your steps. But how do I get rid of that minus ax and put it on the left? I would add it. That's right. So I'm just going to put plus ax. Everybody okay with that? You could have done this. You could have put plus ax right there if you wanted to, but I don't know if that's really needed at this point. All right, so I got the x's. So I got rid of this x, put it over here. So this has a b and this has a b. Where do you think I'm going to put that? I'm going to put it on the other side, okay? So let's do that. Well, what do I have already over on the right side? 5b. I got to get rid of this plus 18b. How do I do that? I subtract an 18b. Make sense? Okay. So I got rid of that. Put that over here. So really, the only thing I did is just put the x's on the left-hand side, put everything else on the right-hand side. I want to solve for x. I got an x here and an x here. So I have an x that's in common with both of those terms. So what I do, I don't know if I use this word this year or not. You've done this in Algebra 1, but I'm going to factor out a common x. So I got an x here, factor out the x. So if I factor it out, when I factor it out, I'm really dividing. So what is 7x divided by x? It's just 7, isn't it? Put the plus. Now, what do I do here? I'm factoring out the x from this whole thing. What am I left with then? An a. Just put plus a. It's the backwards of distributive property, isn't it? Because if I distributed this, x times 7, that'd be 7x. X times a, that'd be ax. I just did the backwards of the distributive property. That's factoring. Equals, what can I do here? 5b minus 18b, same terms. So 5 minus 18 is negative 13b. You guys did this in Algebra 1, didn't you? Do you remember? It's been a couple years. I bet you did. So I got to get x by itself. Well, you were taught it. I'm sure you were taught it. Maybe you did it, maybe you didn't. How do I get rid of this 7 plus a, or you could write it a plus 7 if you wanted to, it doesn't make any difference. How can I get rid of that? What is that parentheses doing to that x? It's being multiplied. How do I get rid of something that's being multiplied? Divide it, that's right. So I divide it by 7 plus a. What do I have to do over here now? Divide it by 7 plus a. So that cancels with that because that's being multiplied. I got x equals negative 13b. Now you could keep it 7 plus a, but I kind of like it like that. It doesn't make any difference. 7 plus a plus 7. And there you go. Now there's one little extra thing they put in here. If you don't put this in here on a quiz or a test, I probably wouldn't mark it wrong. But they say this. I don't know if we talked about this in here. I know I talked about this in one of my classes. It might have been the pre-calc class. I'm not sure. But if you have a fraction, you have a variable in the denominator, what can the denominator never be equal to? 0, right. So the a plus 7 can never be 0. Now, can a be 0? Sure, because what's 0 plus 7? It's 7, yeah. But that whole denominator can't be 0. So that whole a plus 7 cannot be 0. So what can a not be equal to? Negative 7, that's right. Subtract 7 from both sides, so a cannot equal negative 7. So technically, this is also part of your answer. These kind of go together. But on a quiz or a test, I'm not going to make you put a does not equal, or is not equal to negative 7. Right? But you might see it. If you flip in the back and you look at the answers, right, if it's an odd problem, you may possibly see that. You just need to know what that means. All right? I'm not going to require you to write that, but technically you need to, because you cannot put every single number in for a here. Okay? If you put a negative 7, then this doesn't exist. Then you don't have an answer. So that's why they did that. Okay? Let's do one more. This one's kind of a combination between the two we just did. This is example 5. And this one says solve for a. So they're going to put, solve for a. So you're going to have more than one variable in here, and you just got to get the a by itself. So here we go. This one barely has any numbers in it at all. But that's what algebra is all about, isn't it? Using letters to represent numbers. Here's the only number they give you, the 2. All right. What's the worst part about this problem when you first look at it? The fractions, absolutely. So what did we do the last time? Multiply everything by the least common denominator. That's right. So I got a b and a c. What do I do for that? What's the least common denominator? Least common multiple of b and c. What number does b and c both divide into evenly? I'll just show you. Time's running out, so I got to do this quick. So a bc. Everybody see that? I just didn't hear you. And then you got to multiply this by a bc. You got to multiply everything, okay? If you multiply one side, you got to multiply everything on the other side. And then, since that's in parentheses, I'll put that in parentheses, and I'll put the bc right here. Now, why did we do that? We did that so that the b and the c on the bottom will cancel out. So that b cancels out with that b. This c cancels out with this c right there. So now, let's redraw it. Not redraw it, but let's rewrite it, make it look a little prettier. So now, what do we have? We just have a c being multiplied by this, don't we? I'll tell you what, let's just write it down. Instead of trying to do too much, let's write it down. They canceled out because I got a b on the top, b on the bottom. They cancel out. What do we got here? We got a bcd, don't we? Minus, what do we have here? We got a b. I'll tell you what, let's put it out in front. Is that all right? It just looks a little nicer out in front. And then what's in the parentheses? A minus 2b. All right, let's distribute. All right, even though they're mostly letters, we know what to do with these, right? So let's do it. This is AC plus C times C, which is C squared, equals BCD. We don't really do anything with that one right now, but we do have to distribute this. But recognize there's a minus in front of it. So it's going to be this times this. So negative BA is negative. I'll tell you what, let's call it AB. Is that all right? Instead of BA, just put it in alphabetical order. And then a minus B times a minus 2B. It's going to be negative times negative is positive, and it's going to be what? 2B squared. Why are we packing up? We're not done this yet. So now what do we want to do? We want to solve for A, correct? So I need the A's all on the same side. So I already got an A right there, and I got an A here. Watch this carefully. I'm going to go real quick. So add an AB to both sides. We're going to subtract the C squared. So I already got a BCD there. I've got a plus 2B squared, and then I got a minus C squared. Almost done. Almost done. Hang on just a second. Factor out an A. If I factor out an A, I get C plus B equals all this stuff. All right? Copy, paste. Give me a second. Almost done. Then I got to get A by itself, so I divide, whoopsie daisy. I divide by a C plus B. So I divide this whole thing by C plus B. I like it B plus C better. I'll just write it like this. So that cancels, and that is your answer. I know I went kind of quick because time was running out, but there you go. You could always go back, look at it. You could do it yourself, slow it down a little bit, but you got all the steps. Here's your homework. You need to practice that, okay? Because some of you guys probably got lost halfway through it. You got to try that yourself. You got it in front of you. You got the video. You can always rewind it a couple times and come up with that answer, all right? Listen to my steps. Listen to the explanations. If you do it a couple times yourself, you should be able to figure it out.